My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Go Cloud Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the Go Cloud team.
Welcome, everyone. We're here to announce our brand new AWS Advanced Networking Bootcamp, which is going to start Friday. Tonight's the chance for you all to meet the instructors. I'll be one of the instructors. Mark is one of the instructors. Mo is another one of our esteemed instructors in this program, and Benedict will be joining us soon. Together, we all have about 60 years experience to put this course together for you. I can tell you, I'm excited about it because we've got all day Friday, all day Saturday, all day Sunday. I've been a network architect now for, wow, almost 30 years now. I'm going to say 25. It's going to make me feel a whole lot better. And I can tell you, after all these years of experience, that if the network is not right, nothing will work. And it's the thing that no one ever thinks about. They think about their software, they think about their applications, they think about their servers, but they never think about the network. And when people don't realize that the network is the foundation to all, and they don't realize that nothing works without the network, everything falls apart. You want a high availability network or a high availability architecture? It's going to be dependent on the network. Many things, but the network are going to be one of the most critical and fundamental things. So we're here and we're going to teach this program for you. We do this completely free because our world is training people for architecture jobs. You know, getting those best jobs, getting promotions, negotiating $100,000 plus raises, mastering the interview, and getting the best paying jobs in the world. That's what we do at Go Cloud Careers. But, you know, certification is a piece of the component. It's one that we believe should be free. The other reason we do certification free around here is you're just not going to find a collection of 3 CCIEs and a CCNP with 60 years experience teaching an AWS Advanced Networking course. Everything else that's out there is taught by someone that never worked in networking, doesn't know networking, they're pushing a certification, and it's just not fair to y'all. You're going to do this. We want you to learn something. We want you to understand it. And you can't explain what you don't understand. And I can tell you, the two folks that you see with me and Benedict, they know networking. I get in a conversation with Muhammad over there, and he'll introduce himself in a minute. And sometimes it scares me because he reminds me of exactly how I was when I was his age, getting down and dirty with the networking. And it reminds me how much I miss of it. And I see that energy, enthusiasm, and passion there. And when I get deep and down and dirty with Mark, getting geeky with some of these interesting things, I feel that same feeling. So I love it. I love networking. And that's what we're going to talk about. So for those of you that don't know me, I'm a network architect. My CCIE number is 7417, which is pretty scary because I passed it in May of 2001. And this is basically my 23rd anniversary of the CCIE on the 17th, which happens to be exactly when we're doing this boot camp. I had the chance to be a principal architect at Comcast, a principal architect at Riverstone, which is now Nokia. I've been a chance to be a lead architect at Cisco. I got to work on Wall Street and design systems for banks, design systems for the world's largest internet service providers, and I love networking. And I'm the CEO of Go Cloud Careers, and I don't get to get geeky too often, but when we talk networking, I might take my CEO hat off, put my propeller hat on, and have some fun because it reminds me of being young. Let me introduce you to Mohammed over there. Mo is unbelievable. I got to see him in person. He's a good boxer, by the way. He's a very strong, fit guy, in addition to being a really great network architect. Mo, why don't you tell us about yourself for a few minutes?
Hello, everyone. My name is Mo Bogazia. I'm a network architect with over a decade of experience in the field. I love networking, and I got introduced into AWS a couple years ago. And what I found out is that cloud is really, the basics of networking are the same, whether you're on the cloud or on-premise or whatever environment you're in, you will need networking, right? And this is what's special about this course. So I'm very happy to be one of the instructors for this bootcamp, and I'm looking forward to provide some knowledge and learn from you. Thank you.
So I'm excited to have you on here, Mo. I know you. I have tremendous respect. I've seen what you've done. Benedict and Mo have gone behind the scenes and created a tremendous number of labs to kind of get geeky and show you how to do it. I'm excited about that. I'm an architect. Architects don't typically touch the technology, but we have engineers and network engineers and cloud network engineers that are interested. So we got you some of those labs. Now, Mark created some other more important labs that I'm pretty excited about. So when you're in the AWS environment, a lot of it's going to be hidden. What's going to be hidden from you is it's a cloud and you can't see the underlying technology. And if you can't see the underlying technology and you just click a couple of boxes in a lab, you can't learn how the underlying technology actually works. And without understanding how the underlying technology works, you're not in a position to design it. Kind of like cooking. If you don't know what a stove is and you don't know what, say, garlic, olive oil, salt, pepper, and oregano is, and a lemon is, and some chicken, you can't make souvlaki. And I only know how to make souvlaki because I only know how to cook Greek foods, but that's neither here nor there. But the point is, if you don't know all those ingredients and how to use them, you're not going to be able to put it together. So Mark's got some real network labs that you'll be able to download. You'll be able to watch them, and you'll be able to learn what goes on maybe in a switch, and how routers actually forward packets, and how data gets from point A to point B, because you won't see it in the cloud. And by giving you some of these fundamentals, which Mark is going to work on, if you're dealing with a VLAN in AWS, Azure, Cisco, who cares? It's the same VLAN. And if you're seeing how this 802.1q trunk works, it doesn't matter where you're at. And if you're understanding an interior gateway protocol like OSPF, if it's a Cisco router or a Juniper router or an Arista router, it doesn't matter. You know, whether it's BGP, it's kind of the same thing. So we had some fun stuff. We've done a subnetting workshop for you guys ahead of this. Mark and I got geeky. What did we do? A 7-hour BGP workshop, which we did completely free for you guys. So there's that. Mark, now why don't you tell people about ourselves? Now, I will tell you, Mark is also a Cisco Certified Internet Expert, and he's our Chief Technology Officer. But here's a chance for him to play as well.
As Mike so kindly introduced me already, my name is Mark. Last name is Milovanovic. I've also been in networking probably close to a decade now. My predominant expertise was within a managed service provider. So even though I didn't get my hands too much dirty when it comes to the local area networks, such as with spanning tree, VLANs, trunking, let's just say that wasn't necessarily the most complicated aspect. But the beauty about the managed service provider space was, and as we'll see also as we get into the AWS Advanced Networking workshop, is that you get exposed to technologies that you otherwise would not get exposed if you're simply an architect or an engineer on the enterprise side. Meaning you'll see and use BGP a lot more. You'll actually have to work and understand how MPLS forwards traffic in the data plane, how the control plane is established. So all those things I had the opportunity through the managed service provider realm of learning, getting dirty, and then at the same time being able to work with different customers, finding them solutions to a particular business pain point that they had and try to resolve it with technology. So in either case, it's I enjoy networking. It's a passion of mine. And even more than that, I love being able to help people, and I have throughout my career, with technology on how it can improve their business. Same as with Mo and Mike. That is the, as they say, the cherry on top of the cake, the icing on top of the cake, is to be able to take something that's complex and be able to resolve some of these pain points. So I'm very excited for not just the AWS workshop, but as well as for the time that you've taken all to join us today. And hopefully we'll have a fun time. And between the three of us, we'll figure out how many CCAs does it take to figure out something as we want to say, as fundamental as the OSI model, even though for some reason the OSI model is more historical than actual practical. But I digress for right now.
Thanks for that, Mark. So we'll have fun. Benedict will come in soon. He's got well over 10 years of experience. He also holds an MBA and a Cisco Certified Network Professional, in addition to the cloud type thing. So, you know, we're here. We're doing it. We love it. So in the chat box, my team will provide the link to join this free weekend. And there's also going to be in the description of this video some free information. Maybe your desire to become a cloud architect. We've got a free webinar on Thursday. You can join us, for example. Want to know, and the free information in the description of these videos. Want to know how to earn more in tech? There's some free documents for there too. And to get a little extra geeky on networking, I got 2 more networking surprises for you. We have a software-defined wide area network video coming out, which I personally recorded and had fun with. You should see it this week before the boot camp. And we also have a secure access service edge, what is SASE video coming out. Because, you know, in the course, we'll talk about, you know, VPNs, and we'll talk about direct connections. But understand we've got some new, better VPN opportunities that we can use. Things like software-defined WAN that'll kind of merge the gap between the traditional private type line, i.e. an AWS Direct Connection, Azure Express Connect, and the VPN, which gives us more like normal private line performance as well as there. So we'll get fun. We'll get geeky and all these things. Benedict will be joining us soon. You'll get to meet him as well. He's another guy that I'm totally impressed with. He'll be joining us from Canada. He was in Nigeria about 6 months to a year ago, working in networking in Canada. He's fantastic as well. Got to know him over the course of a couple of years. So there's that. So join us on the How to Get Your First Cloud Job webinar on Thursday. We'll talk about what we do as cloud architects. If you want to be like a cloud network architect, that's okay too. You can ask us that question and we'll tell you how. Have some goal to do some cloud network engineering. Guess what? We'll probably talk about that too if you want. We can interview on these free webinars. We can check your skills. They're free. We really just want to help you know what the role of the cloud architect is. And of course, we run webinars for AI architects and enterprise architects and cloud architects. But that's because we want you to get the goals. And whenever you want to build your career, you know what you need? A plan. You need to know what you need to know for this job. I can tell you most of my life in career advising, because I've spent more than 2 decades helping people get their first tech job, they learn the skills from all the wrong careers, the skills from other people's jobs. So we're going to be here. So we're going to be here for networking, because without the network, you've got absolutely nothing. So I'll give you some examples of some networking things that most people don't think about. And then maybe Mo or Mark can comment on when they've ever seen this happen. Mo or Mark, have any of you seen people that didn't know how to properly IP address the network, and in the end the routing tables got crazy and it caused routing problems?
Absolutely, more common than anybody would think, really.
So
I would actually say, surprisingly, what I've seen many times happen is that people had a total disregard for who was using what IP address. So even if you got lucky and the addressing was correct, they thought it was a free fall and just grabbed anything and everything. As you can imagine, if you grab the IP address that was assigned to the local interface of a router facing the LAN, ooh, you have some fun times trying to figure out what the problem is there. And of course, as always, finger pointing. That's always going to be the fun. What about you, Mo? What have you seen happen on your end? I'm guessing a thing or two, right?
Absolutely. IP planning is such an essential part. And unfortunately, what we find is it's not a job that is left to the network team or the infrastructure team. And what would happen is the different departments try to kind of like do their own IP planning. And then by the time it gets to us as network engineers, we're going to have to either give them the bad news that they have to restructure their IP planning, or maybe do some weird of magic tricks like doing NAT, private to private NAT, or some sort of a solution to an issue that would have been prevented very easily with proper IP address management, some sort of an IBAM solution, and good documentation, really.
yeah, because we get that wrong. Everything falls apart and most people don't know it. And I see it every day as a network architect when I redesign people's systems. How about have you ever worked where one company buys another company and they're using overlapping IP addresses?
Yeah, we actually, that's something that happens. We acquire different companies on regular basis. So that's a big issue that we have to deal with, right? And a lot of the time, you have to come up with a kind of a phase one where you have to contain and maintain their IP address schema while you actually enroll them into your network. So it's something very common, actually.
Yeah, it's a lot more common as people believe, and the planning that goes into trying to do that type of merger is insane. And we're talking just at the IP addressing level. Could you imagine if you are trying to join either two of the same routing protocols, such as OSPF, and now you got to merge them? Or even worse, let's say that they decide that they want to revert to one routing protocol of another. Now you have to figure out where my redistribution points are going to be so that you can slowly phase out the previous routing protocol's domain. It can come quite complex. It never is a one-man job, of course, as well. And let me just tell you, you're not going to enjoy those maintenance windows when they start showing up in the middle of the night trying to cut over a network and trying to verify, of course, if all the resources, the application flow, everything is working. So it's a daunting task, to say the least.
It really is. And before we get to some other networking things which are important, which we'll talk about, I want to welcome Benedict here. So everybody that knows me knows I love cats. And Benedict is like a lion. And here's a lion. I met Benedict about 2 years ago, and he came in real quiet. And it wasn't until I heard Benedict speak that I was like, wow, who is this guy? And look at the amount of knowledge he has. He snuck up on me like a lion. And when you actually listen to Benedict speak, the level of knowledge he has, his ability to explain technology is truly incredible. He's a fantastic network architect. Quite frankly, he's a fantastic cloud architect and a cloud network architect as well. But Benedict's a rock star. So he's going to come in, and he did a lot of hands-on labs as well for you guys to demo a lot of these things. And I got to tell you, if you know Benedict the way I've met him, you'll really like Benedict. So Benedict, you want to say a few words about yourself? I'm so excited you're here.
Thanks, Mike, for those kind words. It's really a pleasure getting to work with you to share knowledge and help people all around the world. Um, I would say it's fate that our paths crossed, and we are here together, um, ready to offer some more content to the community out there. Um, I've been working in tech for about 10 years now. Started out in Nigeria and currently in Canada, and I've loved every moment of it. Um, I would like to say that you offer some kind of mentorship to me, Mike.
Thank you.
Um, and it's been very helpful in my career, trying to realign my way of thinking as an engineer into more of an architect. That has been a good thing for me. And I continue to learn because, we never stop learning. So
No, we don't.
I'm happy to be here. And it's nice to see you guys, Mo and Mark, as well.
So there, now you got to meet Benedict, and I tell you, he's incredibly impressive. So now you've met the four of us. Benedict, you have over 10 years experience in networking.
Yes, I do.
And Mo has more than 10 years experience in networking. And Mark has more than 10 years experience in networking. And I don't want to say that I have 30, so I'm going to say that I have 25. And then
That sound old.
Yeah. You know, I think about this, and we'll get into some more of the reasons we're teaching this. But I still remember my 2400 bit per second modem. And when I had that and I was able to dial up and connect to the internet, and I was able to send an email to my relatives in my village in Greece, Naparamos. Of course, they had to go to an internet cafe that was in a village called Elefsina to actually get the email. But was I able to send a message that was like that, and instead of paying, I think it was Bell Atlantic, they're now Verizon, $4.25 a minute to talk to them, because that's the best we had, and we could get a calling cord which would drop it down to like 99 cents by dialing this like 80-digit phone code that would take you on one system to another system to another system. It just showed me what the networking could do. And the next thing I realized, I've got routers and switches in my house and ISDN systems in my house, and I'm building networks all over the world. And then my wife's like, you could actually get a job in tech. You don't have to just do this stuff for fun. And then that started the things. That started my CCIE journey. 6 months later, I was a CCIE working at MSI WorldCom and then designing systems on banks. So the network is kind of important to all of us, you can tell, right? We love it. But, we already gave you 2 use cases of where people don't think of the network. Security. Did you know that 50% of all hacking events happen in the cloud? 50%. And not all, and the cloud doesn't have 50% of all workloads. So here's the thing. In the data center, people think about network security. They think about it. They realize what you can do on the network. If I don't have a route to something, I can't reach it. Why do you think a lot of rich celebrities live on little islands that you need to take a boat or a helicopter to? Or go to the Burj Al Arab in Dubai. It's beautiful, believe me. I've stayed there. You got to either drive over the ramp or take a helicopter to get there, because that way they can kind of protect you. Same thing in networking. If you don't have a route, there's quality of service things that can be done in networking to prioritize real traffic versus worm traffic. There's all kinds of network-based intrusion detection, intrusion prevention. There's a whole lot of stuff that we can actually look at. We've got our next generation firewalls. There's so much stuff on the networking related to security. I view identity and access management as the last component. The network is the primary component. So if you don't know the network, chances are you're going to get hacked too. And we get back into these networking things, and the network engineers when I was a kid, here's how people would say it's not working, and we'd say the network's working because I can ping there, I can perform a trace route to it, and I could telnet to it. Now we don't use telnet anymore, but that was kind of funny. But the point is now the network's everything. You want a Hadoop cluster all over the world, you better have some good high performance, low latency networking, or it's just not going to work. You want to deliver IP-based video, and there's video everywhere. Without a good network, it's not going to work. You want to have your voice, it's not going to work. You want to create an expert network where you try to call me to talk about BGP and I can't pick up the phone, so the call then routes over there to Mark. And when Mark can't pick it up, it goes over there to Mo. That's unified communications, which is a huge form of digital transformation. Can't do that without the network either. And whether you host those servers in the cloud or you host them in a data center, it really doesn't matter. It's all the network. And that's why we get passionate about the network. Because all of us have seen what happens when people don't think of the network. I know Benedict has, I know he has, and I know Mo has, and I know Mark has worked with plenty of environments where people don't think about the network. I've seen banks that had network outages every day because they had a Linux engineer doing networking. And I love Linux engineers. They're awesome. They do Linux, but not networking. Most network engineers wouldn't know what to do with Linux either.
You know, it's quite funny, Mike. You and I, we've had these conversations before where technology has progressed to a point now that we're at that it just works. And because it just works, when it breaks, that is where everybody is up in arms and they're trying to figure out what just happened. This was always working. And the fault really lies in the assumption was made. Because it is generally so foolproof, which, by the way, it is not. If you really think it is, look up submarine cables. It takes one snip and you can cut off most of the entire continent. But besides that, it's because how reliable networks have gotten that when something goes wrong, it throws us for such a loop. Because almost everything relies now on having connectivity, either internally or also to external sources. So I liken it almost to needing networking knowledge like it used to be back in the day when computer typing came about, right? Remember on the resume, it had to say, you need to be able to type 30 words per minute, and then it moved up to 40, 50, 60. And then eventually you had to be as lightning fast as a computer typing 1,000 words or something ridiculous a minute. So, and I've seen that now even among different domains. Somebody who likes security, it's expected for them to have basic fundamentals of routing and switching, for example. You bring in our collaboration team, the voice and the video. Well, guess what? That service runs on top of the networking infrastructure. They're expected to know the basics about networking as well. So we can see in all these different domains, security, voice and video, even in the application design and system design with virtualization, all of it depends on interconnection between computers. And that's why I think it's so important, irregardless if it's your main vocation when it comes to networking, or if it's not, it is critical to at least have the fundamentals so that you can slot in there and then provide the service that is necessary. So, but yeah, just remind me of the words per minute. What's that, like 30 years ago?
Yeah, and that's the thing we expect it to work. So like, and as industry transition, I saw somebody post on LinkedIn today that you should learn prompt engineering. Prompt engineering is dead in 2 years. And here's the reason prompt engineering is dead. The AI systems being developed support better and better language models that you can ask it a generic question and then they'll know how to answer it with real good language in a year or two. That's a career of yesterday. It was big last year. There's a little bit left and it's dead. So you don't want to waste your time learning that. But if you don't understand networking, nothing will work. You won't be able to design a system. You won't be able to create availability. And I can always tell if somebody understands networking, if I give them a back question. If I ask someone, how do you build a high availability cloud? And they say, we can do it on AWS and all we need is 2 availability zones and 2 regions. I say, you don't know networking, because they don't understand that one network problem could take down that entire cloud. They don't understand the control planes of the cloud, because a single control plane failure could take down a cloud. They don't understand how a security event, which is on the network, can take down an entire cloud. And that's why, we saw so many networks go down globally when the clouds had minor failures, because it's all networking related. You think you're connecting to something that's here, but it's really connected somewhere else, which is connected to somewhere else. And one little routing problem or BGP problem, like the whole Google Cloud went down due to a BGP error. And, that networking piece is there. I can always find my networking people because their systems are they're very elegantly designed. They have lots of redundancy in all the right places. They understand the governance because the networking people probably learn worse than anybody else. Here, let me just go to the router and type one thing on an interface, and they literally took down an entire system. Because normally, you get a software developer, they focus on their application, right? They focus on their one application. What do they break? One application. Now you've got somebody that goes into a single core router to make one little fix. and the entire network comes collapsing down. So, the change control processes and all that came out in networking as well. All that high availability thing. So, Mo, Benedict, you guys want to talk? You guys are going to be doing a lot of instruction here.
Yeah, I mean, nowadays, networking is very crucial for organizations, and it is usually underestimated. But if you look at a very high-rated certification such as the CISSP, they have one domain dedicated to communications and network security, which shows you how important that subject is. So, in one of the organizations I was working in, one of the IT security guys came to us and said, "We see an IP address 192.169.1.30 accessing the Active Directory. What's going on here?" So it takes a network engineer to understand that this is a public IP address which should not be connecting to your private IP addresses, your Active Directory in this case. And so there is a possible intrusion, right? Um, a security engineer who doesn't have the basics of subnetting will allow this traffic to go unnoticed, right? And then, there could be privilege escalation and many more troubles down the line. So, I mean, networking is very crucial, and it's very important for security personnel also to have the basic fundamentals of networking, because it will definitely help you in your career. So, VPNs. We know that we've been told that having VPNs to your remote office is usually safe, especially when you're working out of remote locations such as hotels or connecting to, public Wi-Fi. But the question you need to ask yourself, as a networking professional with a security background, is it possible for this VPN to act as an attack surface? So the VPN in this case is acting as a bridge between your PC and the private organization. And so there could be some lateral movement if your PC is infected into the organization. So these are the kind of things that networking professionals with security background deal with on a day-to-day basis. And I would say that network engineers are a bit underestimated, in my opinion. They
Usually.
should be paid more and respected more, if you ask me. But yeah, I mean, networking is key for every IT professional out there. Understanding the basics, the flow of communication from one part of the network to the other is very helpful, and it pays to invest in this knowledge.
Yeah.
Absolutely. Yeah, on Benedict's point, and also what Mark was saying previously, not only is networking is the bread and butter of your infrastructure, it is the basic component that will connect point A to point B. So it's necessary. Not only do you need it in order to be able to connect your network, but whatever field you are in within the IT industry, you need to know the basic network knowledge in order to have more context when something happens. Just like a very excellent point that Ben demonstrated is that knowing the difference between a private and public IP, that will give you more context of what this IP is, right? So really, like these simple things, and this is why we built the bootcamp. The way we built it is that we put a lot of networking knowledge there, because it's really impossible to teach you what AWS networking is without knowing what networking is to begin with, right? So AWS is just more of an abstraction of what we know as networking people, but it's still built on the same network knowledge and components that we all know of. And that's why we started with the knowledge of what networking is, what are IP addresses, subnetting, OSI models, and we take you up from there. So you'll find that, if you follow through, it will really start making sense as you go. We build, your knowledge will build on top of each other in order to get there.
And Mo brought up a good point. And this last 2 weeks ago we did the subnetting. Then we did the BGP. Tomorrow is SD-WAN, I believe. The day after that is SASE. Then we're going to run this boot camp. There's no networking in the AWS Advanced Networking curriculum by nature. The AWS Advanced Networking is a nothing exam for someone like Mo, who's a CCIA, that says, oh, now I want to get certified in AWS. I'll just learn those AWS names for the things that I already knew, and I pass it. The problem is most of the AWS curriculums don't teach the technology itself. And if you don't know the technology, and then they want to talk about a transit gateway, it all feels foreign. But to Mo or to Benedict or to Mark, and it's like, okay, well, the transit gateway is really replacing what's called the BGP route reflector due to non-transitive properties. It pretty much enables this, and this, which is just basic networking. Then it's nothing for you. So that's why we're going to give you some of the underlying technology. Mark went in there and built all those underlying networking things for you to get a feel. That's why we have all these other free networking things we're doing ahead of this. So in these 3 days, when this team goes out there and works hard to make sure you know it, you'll have the fundamentals to be able to make much more meaningful use of it. You'll know what a VLAN is, what a tag is. You'll understand the IP addressing, the subnetting. You will know what a next generation firewall is versus an AWS WAF, and why we would want to use a next generation firewall. You'll understand, we'll probably, if you want us to do, we'll get into some load balancer geekiness, and we can talk about real load balancer architectures where we stack network load balancers and application load balancers, because we want you to learn. And we'll get into that. And that's really the key. When you understand the fundamentals, everything else is just silly easy. It really is. But without the fundamentals, oh, it's pretty hard. And, the security components, the availability components, Benedict and Mo talked about, it was Benedict that talked about a VPN, right? Now You're just a generic, now you're a cloud architect and you're not even working in networking. And you've got to deal with 50,000 remote access employees. So do we design a demilitarized zone for the VPN concentrator? Most likely. Do we leverage a pre-made service? Okay. Now the users, do we create what's called split tunnels? And I'll tell you what they mean. Or do we tunnel everything? So I've got 2 options with the VPN. Let's say I have my 20,000 remote users come in the VPN through my internet access, and now they want to go out the internet. Guess what? They're now protected by my corporate firewalls. But now I've got 20,000 people that are actually using my internet access as a company. And what does that mean? I might need, 10 gig connections across different ISPs running BGP to them. Whereas if I split tunnel them, I can send only corporate traffic down the tunnel and send their local traffic out their local internet, out their local PC, which saves me a lot. But what if their local PC gets infected? Now that can come back in the network. So we're going to have to think of those architectural trade-offs. There's a huge cost to not split tunnel financially. Huge bandwidth cost. But what are we doing with security? And it's only when you understand networking can you think about, how do I deal with the remote access users? It's only when you understand networking that you can think about, I've got a storage problem and I need really low latency. I've got this banking application that a millisecond of latency can make an extra $200 million a year. Do I stick it in the cloud or no? And if you don't understand those wide area networks and latencies, you don't know where to design it, and you put it in the wrong place, and hundreds of millions of dollars are lost if there's not the networking. If you don't understand where things can go wrong and how things are going to break, anytime somebody says, guess what, we got a brand new exciting feature, it's changing the world, you might actually tell the CIO at your end client that, and they might laugh at you and kick you out of the room. There was a person I saw on made a comment on AWS Private Link about a year and a half ago. He was a really nice guy. I knew the guy. And he talked about the amazing thing that AWS can build you a virtual connection between 2 places on the AWS network, and how it's legendary and it's going to be transforming and every company is going to adopt it. And I knew the person and I reached out to him. I said, you're right. This is extremely exciting technology. It was really exciting when Luca Martini actually did this back in 1999. But now The cloud is just doing what we did, 25 years ago, and it's now called private link. It used to be called the Martini tunnel, which then it later became VPLS. And you need to have the underlying knowledge, because when you know the foundation, it's there. There's a song, I think it was The Who, Meet the New Boss, same as the old boss. And if you know that old boss, that network, and you know it well enough, the cloud is simple. Because what is a cloud? It's somebody else's data center, which is a network with a bunch of servers and storage. That's it. So that's why the network is important. So I'm excited about it. So, you guys can talk. You guys in the audience have some questions about why we love networking so much, or how important networking it is. Ask them, because we want to help you build your best careers.
Well, I'm going to play one of the audience for a second, because I have a question, and I probably don't need to raise my hand. So that was a little awkward. But in any case, it is out there now in the internet. We can't get rid of it. So I wanted to piggyback on something Mo said, and I wanted to get both Mo's and Benedict's opinion first, and then I want to hear from you about it, Mike. So there is certain verbiage or terminology that we read about them, we hear, we use them in our speech, especially when it comes to networking. And Mo touched on it. He said abstraction. So, and then you touched on the fact that what a cloud is, irregardless if it's an ATM cloud, if it's a frame relay cloud, an MPLS, or in this case, it is is this going to be a new word? I think cloud. In any case, cloud service provider network, okay? Let's put it that way. There is always some form of abstraction going on. As you, Benedict, and Mo went through the material and prepared it, can you first of all explain what abstraction means to you and what you have seen in regards to how much abstraction there is between traditional networking as you've come to know it, compared to how, in this case, we're going to talk about Amazon, how Amazon implemented it in regards to this exam?
Yeah, in the context of AWS, the abstraction layer would be the actual console that you see, the ABI that you interact with, right? So you have, AWS has a massive infrastructure, right? You're all over the place. They have their servers, they have their switches, their network connected in a certain way, but you don't see that, right? You see the abstraction layer on top of it. And that's really what you interact with, right? Whether you send API, REST API calls, or you use the AWS console, or maybe use Bash and through a CLI. At the end of the day, an abstraction in the cloud world will be their hypervisor, right? Whatever you deal with, right? Versus on traditional on-premises data centers, you actually interact with the actual hardware, right? You have your switches, you have your routers, any connection that you want to make, you actually have to sometimes, you have to plug things in, you have to create your connection. It's over 100 meters. You have to think about, I have to use fiber in this case. And there's more of a, you don't have that instant connections that you have when you deal with AWS abstraction, because they've created all that connections for you. And really what you're doing is just sending API calls to activate specific connections. So the drawback obviously here is that because of the abstraction, you don't really know what is happening under the hood, as we said.
Yep.
And then if something goes wrong, you don't really understand the what's under the hood. So you have more of a surface level understanding of the actual infrastructure versus your own premise, because you built it. You have access to everything, right? You know the connections. Mm-hmm. So there's some limitations with the design. So there has to be, I would argue that there's more creativity. There has to be more creativity, because now you're restricted of what really you can do, and you need to really think about everything you do in the cloud. I think it's even more important, and that's something that is lost. That's the art that's lost in the cloud, because everything is instantaneous and it's really plug and play. You click things around. Maybe plug and play is not the best word, but everything is easily created. People don't put too much thought into actually designing before building that infrastructure.
So what you're saying is that what AWS, or in general, anything that eventually virtualizes something else. In this case, we're virtualizing the infrastructure, including the actual networking, the storage, and the actual router, switches, firewalls in the cloud. So what AWS and others have done is, by abstraction, basically, they've hidden the complexities from the actual infrastructure. And for somebody like yourself, myself, especially Benedict and Mike, that causes a little bit of a confusion because we're so used to seeing all of the little nuts and bolts and have the opportunity to try to figure out how can we manipulate these to kind of affect an endpoint or outcome. Have you found that to be a challenge when it comes to AWS because of that masking, that hiding?
Absolutely. I think a big thing in AWS, you really, not only do you ask yourself what you can do with this technology, but what are the limitations, right?
Yeah.
And it comes down to, would I use, I want to connect two VPCs, right? Is it better to just create a VPC peering, or would I use a transit gateway, right? Well, I have to ask myself. It always comes back to business, right? Are we going to expand, or is that it? Are we expecting 100 VPCs or maybe 20 VPCs in the future?
So scalability, right? That's
Yes,
what you think of growth.
Right?
Okay.
Exactly. And then you think about the cost aspect too, right? Because if you connect two VPCs, they're in the same availability zone, then that's free. As of, I think, 2021 is that kind of connection is free versus using a transit gateway, there's cost. But of course, there's trade-offs, right? And some people would think VPC peering is free. It's not, right? You have to look into context. It's only free if you're both the connection from VPC A to VPC B is traversing the same availability zone on both sides, the same region, same availability zone. So it really goes down to like two things, right? The limitations of the technology or the resource that they give you access to, and then the cost aspect, right? And that's where a lot of the planning. That's where you have to do a lot of planning and understanding the limitations and the costs of these resources. And those are things that always update. So you always need to be up, keep up with this technology, keep up with the news. And so that's where like there's a little bit, at least for me, I see because I'm more limited, I have to be more creative and I have to think of everything from point A to point Z.
And then they throw you the curveball also with the cost, right? Because there's cost involved with using the cloud that you traditionally don't, I guess you don't think about it, right? On an on-premise network. Here you're thinking about every minute connection. Is this going to cost me? Yes. How is it going to cost me? Is it going to be ingress, egress? So basically incoming, outgoing. If I use this particular solution, let's say transit gateway, is that going to cost me as well compared to just doing the direct peering between the virtual cloud networks? So it seems like that the cloud, it abstracts or hides certain complexities that would be inherent with normally building up a network, but then they throw it back in with these, I would say, lucrative and yet confusing pricing structures that sometimes keep us away from being able to use, let's say, a solution we came up because guess what? Money is an issue eventually, right? When we're trying to figure it out.
Absolutely. Could have said it better. Pretty much you trade off. There's a trade-off, right? You replace some complexity with a different type of complexity, really.
Yeah.
And what about you, Benedict?
And to add to what Mo has said, you find that the level of abstraction varies according to the cloud model that you adopt. So if you are doing infrastructure as a service, you probably have more control over platform as a service or software as a service. So you need to, have some compensating controls in place because security in the cloud is a shared responsibility, right? So you handle what you can take care of, and then the cloud provider that has presented this abstraction to us have their own responsibility of locking down the systems to keep your assets safe and secure.
So you're putting your trust to a certain degree on them securing the infrastructure that they have hidden from us, and then you're trying to make sure that at least the things that I control, things that I load up, that those are under a certain measure of security. And have you guys heard about? I don't know. Recently there was a story. I'm not privy to all the details, but it was somebody who racked up a ridiculous amount of charges with a what do you call it? AWS Bucket 3 or something like that. Basically, the storage solution. You guys hear about that?
Some people have done that. Google just deleted a large customers account and hundreds of was it how many billions of dollars was it of somebody's records from a big bank. It's abstracted. You can't see it. You don't know what they're doing. Here's another one to think about, which comes out of networking. It's called oversubscription. So for those of you that are new to networking, here's what oversubscription is. I've got, let's say in my community, 500 homes have a 1 gigabit connection to AT&T. Well, we have 1 gigabit connection to 500 homes in my community. So that's 500 gigs, right? Now, do you think they have a 500 gig connection from my community to AT&T? No way. They've got a 50 gigabit connection or so from my community to AT&T. And it's based on the advanced statistical analysis that not all people are going to be using their systems at the same time. I want you to understand that. All service providers, cloud providers do internet service providers, and that's how they make money. They design the same thing you have, and then they mark it up, and then they add more customers than you could potentially put there. And that's why if you ever want to know why cloud computing is considered birthy, and it works great now, and then another time it's a little laggy, and then it works great, that's the reason why. It's abstracted from you can't see. So let's say you will go right now, and you want to spend about $600K on a really good server from Dell. You get 256 cores, you get about 6 terabytes of DRAM, you get some really awesome NVMe drives. On that thing, you could put 64 8-core servers at the server's capability. You've got 256 cores, they're virtual cores, they virtualize to 512, and you would have 64. And that's what an organization is going to do in their data center. They're going to put 64 servers on that thing. Now they go to the cloud, and the cloud provider may sell 100 on that same thing on the basis that not everybody's going to use their servers all on the same time. And they're right. Most of the time, until something breaks somewhere, and then your performance degrades, or until something happens. Anybody remember being stuck at home during COVID, and all of a sudden their gigabit Ethernet connection didn't work to the internet? They got 3 megs, and they were trying to send an email, and the email wouldn't, and that's because the internet service providers were oversubscribed. We have some of that stuff on the cloud. Does it work? Yeah, the cloud works great. It works in the internet world too, but we've got all these things to plan around, and if you don't understand the concepts, you don't know how to design your system to work around this weird level of abstraction that we have. And that's why the more abstraction you have, less control you have. As Benedict, and he said it right, you've got a lot more control over your virtual machines than you do Fargate, which is going to, not that Fargate's not a good service, it's a trade. Do we want the control and the performance, which we can pretty much guarantee ourselves, or do we want the simplicity and elegance of not having to worry about it? What's the business needs? And that's why we're going to approach it, and that's why we have folks like this that are going to come in and really make sure that you understand this AWS Advanced Networking. We're making it free because I saw what existed out there, and honestly, it horrified me. It was just a name of something. Here's how to configure it. You won't know what it is. You won't be able to deal with it. And that's why people tell me this is a hard exam, because they don't understand the technology, and the tests aren't how to configure it. The tests are how the stuff works. We'll make this real easy for you. Our experts are going to help you. And I know that means Benedict and Mo are going to get real geeky on you guys.
I am curious, and I got a question, and this goes both to Mo and Benedict. Maybe we'll have Benedict answer first and give Mo a minute here to think about his answer. So when somebody approaches this type of exam, it generally is, from my understanding, assumed that there is some type of prerequisite understanding, right? They quantify it by 1, 2, 3, or 5 years worth of hand-on skills in networking. Have you found that as you develop the material, that the actual information contained in the official resources was very scarce when it came to the fundamentals of networking, so that you can build yourself up and understand what is something such as transport, such as MPLS and VPLS? How does this concept of not necessarily being in the data path of a route, but rather just doing a computation and sending it out like a route reflector? Is that something that you have found to be the case, Benedict?
Yes. I mean, I went through the material, and there's nothing about networking basics there. there's no VLAN, there's no spanning tree protocol. There's very high level BGP. I mean, the basics of networking are missing there, really. So it's more of a high level networking course. That's why it's good that we're having this programs before the actual boot camps to give people that solid foundation from which they can understand the advanced networking boot camp. So with respect to networking fundamentals, it's completely missing from this exam.
Interesting.
Yeah, I would.
What about you, Mo?
Yeah, I would agree on Benedict. I've actually taken the exam, and luckily I've passed it. And I would say, really, even if you look at the curriculum, you take the exam with the with the assumption, or their assumption is that you already have networking, good networking knowledge, because really you're going to build on top of that. Because that's not without breaking NDA. They're not trying to ask you for the basic networking knowledge. The questions assume that you already have that. So you're really like trying to test how well do you know the AWS infrastructure, how well do you know their different services and how they interact together, and so on and so forth. So I would say it's really impossible to pass it without a good networking knowledge, right? And that's why that was why we built the course the way we did. But also beyond that, they want to make sure that you actually understand how these different AWS services work together. So it's really not about how you configure these things, right? Or how to build it. That's nothing. Right. And I can say that for any exam, whether it's the CCNA, the CCNP, or even the CCIE, it's not about how to do it. That's the easy part. It's really how those different components work together, right? That's where the real complexity is.
Yeah, I remember that was also a gotcha. I think even for Mike, right, during the and Benedict too. Any certification that you take, especially networking related, is the first time you try to figure out what's wrong with the network during it. For some reason, my OSPF neighborship is not coming up. I can't form an adjacency, do the exchange of my LSA database, and you never ever think about it that is there a possibility my routers are plugged in or virtually connected on the wrong access ports, not sharing the same VLAN? Does my actual multicast hello never reaches the other side? Right? So that's where you start thinking about the interconnectivity between the different layers of abstraction, right? The IP layer hides the data link layer where the MAC addresses get swapped. So it's nice to hear that, at least when it comes from that perspective, that you do need to understand that it's not just the simple, this is the technology, this is how it works, but rather this is the technology, this is how it works, and this is how it interconnects between all the other different components that we have, so that we can make a functional network out of the different technologies.
Absolutely. So I know we've got some questions I want to address. We'll get to the questions in 1 second, or comments, and I would encourage questions, please bring them in. We've got our free AWS Advanced Networking coming on Friday, Saturday, and Sunday. It's going to be all day. In case you just got here, here's our instructor staff. It's going to be completely free. Sign up now. The link is in the chat box. My team will pop it also in the chat box. It's in the description of this video. My AI does all kinds of cool little emojis for me in the chat from Apple and its new AI. On Thursday this week, we have a How to Get Your First Cloud Architect Job webinar. We'll go over the architect role. We'll talk about what we do. You can ask us questions. We want to help you get your architecture career done if you want to be an architect. So let's entertain some questions from the chat box, because it doesn't take much to get me, Mark, Mo, and Benedict a little bit geeky on networking, because we love it. I mean, we just love it.
Hey, Mohammed, how you doing? So Mohammed asks, cloud networking solution for multi-cloud. How to be adjusted with business needs?
So Mohammed, that's not going to be a 2-minute answer. So that is what a network architect would do. So that's going to require the following. It's going to have to understand the organization's performance needs. It's going to have to take into account the organization's ability to manage the complexity of the solution that we need to design. It's understanding, the availability needs, i.e., what is the cost of downtime? It's understanding the maximum amount of downtime an organization can tolerate without getting any permanent business damage. From there, we can derive, say, an RTO. But even before we think about an RTO from a disaster recovery perspective, which would, of course, be part of this architecture, we need to determine the application of the network availability for the applications themselves. We then need to think about the types of performance that we need across cloud providers, the type of systems that are going to be in terms of cloud providers. We have to balance that with the organization's future goals, future potentially customers. Are they like a business that acquires customers all the time? Is their business in future going to be static, or is it going to be more dynamic because they're in an environment where things change differently and we have to allow the ability to have a different type of foundation so we can allow new services? That's why we have our Cloud Architect Career Development Program, because that's about 700 hours of training to answer the question that you're asking me right now. And there's actually, it's probably 800-900 hours of training in our Cloud Architect program at this point to be able to teach this. And that's why we're so successful at getting people hired. But we will have on this a free AWS Advanced Networking, which will teach you how to pass the exam. But that's why we have courses outside of our certification boot camps where we teach architecture, because that is a big question you're asking. It's not a simple one that we can just answer in 5 minutes. And quite frankly, I don't think we can answer it in an 8-hour day. It just takes a lot of diving under the hood.
I'll give you a simple example, Mohammed, to kind of bring it back to the networking foundation, and I'm sure Mo and Benedict will have something to say for that. You're talking about an adjustment. So something came up in the business, you already had a strategy in place. Let's say from top to the bottom, so from layer 7 to layer 1, everything has been designed, implemented, it's operational, everything is gravy at this point. Your manager comes to you and says, we're bringing in a new department, and it requires 200 hosts to be available on the network. So if you planned it correctly, let's say your IP addressing scheme, you would have allowed for growth in there. So whatever addressing scheme you had before, you would have had to have a baseline understanding of what the business is, how many people are there, and then try to figure out maybe anywhere from a 20 to 30% growth rate, not just overall, but perhaps even between the different departments that you have. In this case, we will call them IP subnets. So if you do something like that, and there's an adjustment in the business, it becomes a lot easier to be able to grow or scale as your company grows. Now, when it comes to cloud environments, that is the whole idea about cloud, right? If the need arrives, you pay for it and you can use it immediately. You can scale. Sure. Now, if that's the most economical decision to make, again, that would have to be discussed at that time. That's not something that we can just answer, because that depends on so many things, right? Yeah. I mean, think about it. You got to spool up a couple of servers. Well, what kind of virtual machines? What are the stats that you need for the virtual machine? What kind of throughput do you need? Does this need to go back to a database that's on premise or that's at the cloud? How do you access that? What's that going to cost? So from that perspective, there's a lot of it. But I hope that little IP addressing example shows you that if you take it from approach of how can I build in the growth, that will allow you to have a little bit more flexibility. What about you, Benedict and Mo? Have you come across these kind of things where you had to really think about how can we design a network? How can we put something like a safeguard in there in case there's growth in the future?
Okay, absolutely. Going back to Mohammed's question, right? He's asking about multi-cloud. How can you do a multi-cloud solution? And just as Mike and Mark just touched up on, right? You have to understand the business needs, so that takes into account what's a tolerable downtime. Are we looking for more of like an active multi-cloud solution, or is this more of a your cloud 1 fails, you shut it off and then turn on cloud 2, right? And that changes the cost.
Yes.
Based on are both of your data centers technically running at the same time, and then you take you go even further, right? You have to engage everybody. It's really not, it's not a question for you to just answer. You have to involve the application team too, right? Can the application, does the application support DNS-based failovers, right? And that, you'll be surprised, not every application can support that by nature, or just outdated applications, right? Maybe you have to incorporate some sort of an Anycast-based load balancing, right? So it's really not as simple. You should have the knowledge to know how to make a decision based on all the information that's available. But really, like, getting all the information and understanding the requirements and the limitations, that's the hardest part of the job, and that's what Go Cloud Career does. We do a lot of sessions where we dig in into, for hours. We would ask uh, the business to understand exactly what are the needs, the goals, and the limitations, right? So it's not really, there's no, the answer is it depends, and we can't just answer it unless we have the full context.
Yeah, and to add to this, I think the person who asked this question is an architect, or is thinking like an architect.
Yes.
Because that's what they do. They analyze the situation and plan to fix any probable problems. And these kind of situations are not only found in cloud networking as well. You could have a company that is just solely on-prem, and then you are designing the network, and they tell you that there are going to be 6 people sitting on this floor. Now, do you design the subnet for that floor with this .248
No.
subnet? No, you don't, because in the future they are going to expand that floor and add more people, and that's going to mess up your subnetting. So you must constantly plan for expansion, for business growth, and it's just a continuous process.
Yes. And that's the difference between cloud architecture and cloud engineering. Architecture is all about the planning. It's about thinking of every one of these components and how their impact on the system. If you think about general system theory from healthcare, one part of the system affects another part of the system. That's architecture. If we don't drink water for 3 days, we die, right? Why is it we die? What is the impact on the kidneys? What is the impact on the heart? What is the impact on the brain? It's that kind of thing. So sorry, I used to practice internal medicine. Before that, I was a paramedic firefighter. I was a terrible firefighter, great paramedic because I'm terrible with tools, but love being a paramedic, and I did it for a long time paying through school. But that's what we're really trying to get, and that's architecture, and that's why we do what we do. But I know Muhammad. He's over there in Somalia. I got to go see those beaches one day, and he really works hard and studies hard. So I'm really happy he's always around. Good to see you, Muhammad.
Great question. And for everybody else too, don't be shy. Whatever questions you have, if you're curious about what to expect on this upcoming workshop, if you have let's say you have absolutely no understanding of what even AWS Advanced Networking is, make sure you ask it. That's why Mo and Benedict is here, Mike and myself, and hopefully we can answer some of your questions. So here is from, and I think it says the coder, right? I'm seeing that. I'm not going blind yet, right? Yep, it says, it seems that security is another name for networking because it's all about securing the network. Is that correct?
I would say networking is a big component of security, but there's other components of security. So if we look at our packet filtering, like an access control list, it's network-based. If we look at a host-based firewall, like a security group, it's network-based. If we look at the DDoS prevention on a content delivery network, it's network-based. If we deal with a next generation firewall, it's network-based. If we look at quality of service on our wide area networking links, it's networking-based. But there's other parts of security that are not networking-based. For example, we've got authentication, authorization, accounting, otherwise known as IAM. That's application-based. That is who you are, what you're allowed to do, and keeping it tracked. Now, if you're taking your data and you're encrypting it in motion, that's network-based. typically via IPsec protocol if you're in a VPN environment, but it could also be using the TLS protocol, which is actually, still networking based. But, there's certificate authorities. Well, that certificate authority is not network based, but the encryption that's used is network based. That's actually thereafter. Now, what about the people? If I can walk into somebody and I can tell somebody your hair looks really nice, boy, those are nice shoes, and that person will allow me to go to the person's desk and do something funny, well, that's human-based security. So we have to address the security policy. We have to have prevention mechanisms that are both physical, that are both network, that are also non-network. So networking is a major component of security, and you can't do security without an understanding of networking, but security is even above that. That's a question that I really like.
Yeah, I agree with you, Mike. The networking is a crucial component in security. Speaking frankly, if you can't reach a system, you can't hack it, right?
Yep.
So it plays a crucial role for threat actors to perform their nefarious activities. But to add to this, so there's this concept of an air gap system, right? So it's usually just a system in its own network. So just imagine you have such a system in your data center. Maybe the payroll system is just server there in your data center, not connected to the network. It's just for printing employee payroll information. It's not connected to the network, so it can't be hacked, right?
Yes, right.
But if you have a disgruntled staff who has access to the data center, he's going to crash that server, right? So in this case, networking did not play a part in this security breach, but a lack of physical security, physical access control, led to this event. So networking is a crucial part, but there are other important parts: asset security, having your policies as well. Having your policies as well in place, your security policies that determine how you back up your systems, how you implement endpoint security. They're also crucial steps in security.
Absolutely.
Yeah, and I'm going to take a little bit of a different view to Mike and Benedict, to no shock here, and I'm going to stand up for all the networking people out there and say, no, security is not another word for networking. Don't treat us like that. Okay. So what I mean with that is, again, networking is the foundation, the pump, the plumbing, the piping, the road, right? And then everything else is the cargo. Everything else rides on top of that. So there's cargo that's worth protecting. There's cargo that's not worth protecting. So from that perspective, you really have to look at the network as a vehicle to bring about services. So what I mean with that is, there's components in a network. Yes, you should protect them. Generally speaking, you disable services that you don't need active, let's say on your router or on your switches. That way, that somebody who has nothing better to do with their day can exploit these. So that will be part of the infrastructure. But a lot of the security vulnerabilities don't really stem simply from the network. Remember, we have a lot of different applications that ride on top of the network. It starts with, our voice and video. It starts with our software as a service applications, right? So all those things, they ride on top of that, and they add to that the threat scope, if you want to call it that, the threat landscape that we have. So we now need, from a network perspective, think about how do we protect the network from those vulnerabilities as well.
Right.
That's why the cloud has always been one of those difficult things to solve, because it's a shared environment. There, a lot more things have to be allowed on it compared to our personal or private networks. So that increases the threat landscape. And that also forces us to lock down our applications, right? That's why many times you see that we use such things as packet filtering tools like access control lists to limit access to either, let's say, from a source to destination IP address, Many times we can lock down the specific pathway through maybe like a port identification so that we don't allow certain services to run across it. So I would say they're separate, but they're integral to each other, especially in today's landscape. And I think that's why you see such a huge push, especially in the cloud, to work on providing us better visibility of our workflows so that we can figure out how to protect them better, and also make sure that these policies that our security is based on actually travel with our workflows to kind of lock those vulnerabilities down. At least that is my personal opinion when it comes to security and networking. It's not the same, but it is all about securing basically from your physical infrastructure to your virtual infrastructure.
Sounds great, Mark. I know we'll take the next question before we do. If you've just joined us, we've got a free AWS Advanced Networking Bootcamp coming Friday, Saturday, and Sunday all day. Link is in the chat box, the description below. We've got a free How to Become a Cloud Architect webinar on Thursday. Join us. The links of my team will pop in the description as well as the chat box. Let's take the next question. Don't be shy.
From Angel, it helps to learn how virtualization works before learning how cloud system works.
Angel, 100%. If you don't understand virtualization, you won't understand cloud computing. If you don't understand the network, you won't understand cloud computing. And if you don't understand the data center, you won't understand cloud computing. And here's the reason. All cloud computing is somebody's virtualized data center. So you're basically renting a virtual data center. So instead of building your own home, you're renting a hotel room. And that's all cloud computing is. And, you know, Angel, that's why I have all of our students in our cloud architect training actually get to the data center. They come to our data center, they learn virtualization, they work with VMware, they work with, and they build their own clouds, and they get hands-on on every component that made the cloud possible first. And then they learn virtualization. Absolutely, completely critical. Great point.
Yeah, now the question is going to be, Angel, how much of the virtualization should you learn? So considering that virtualization can take all sorts of forms, right? If we look at just networking itself, we have a concept of virtual local area networks. That is a virtual network that we have built by segregating ports on our switches. So that is a form of virtualization. As you move up and you start going into the data center sphere, you'll notice that now we have to deal with virtualizations from all angles. It could be with virtual machines. Now we learn about, about different hypervisors, what type of level of abstraction, meaning they abstract the physical hardware so that we can utilize and share our resources among each others. And then you also get to the point where you start thinking, okay, data centers are huge, thousands of switches, routers. We have multiple physical devices that all of a sudden run abstraction through a hypervisor on it that allows us now to share resources. Now, on top of that, what we're going to add is a virtual network, because otherwise managing everything else becomes complicated. That's where other virtualization or overlay technology comes into play, such as ACI and VMware NSX, right, for example. So from that perspective, though, again, you got to figure out, depending on what role you go for. If you go for an architect role, for example, you want to have a high-level overview of these things.
Yes.
And then depending if you specialize, of course, learn more about it. But if you're not specializing, always know that you can rely on your team for the details, or you do your own research and find the details. So that's one aspect. If you're looking down the engineering side, the depth that you might have to go into it could be limitless. Think about on the back end, Mo described that there's a lot of abstraction, a lot of hiding from the physical infrastructure, both from servers, routers, switches, firewalls in the cloud. Could you imagine the level of depth those engineers and architects need to put together such a cloud? Right? It's going to be much different than what you, I, Mike, and others have to know. It doesn't mean you shouldn't, but it will be different. So just keep that in mind.
Yeah, and to add to that, really, it depends on which area you currently work in. So if I'm working as a network engineer, I wouldn't probably need as much virtualization knowledge as someone who is working in a server engineering role, because that guy's main focus is building virtual machines, taking snapshots, maintaining the whole system. For me as a network engineer, I'm more of deploying firewalls in a virtual environment or network access control systems and stuff like that. So it depends on what your goals are. Do you want to be a server engineer? Do you want to be a network engineer? Do you want to be a cloud engineer? Do you want to be an architect? That would determine how much of virtualization knowledge that you need to succeed in your goal.
Yeah. And all these roles are different, even in networking. Yeah. So early in my career, I helped the providers design their clouds. So I got real geeky in these routing protocols and MPLS and traffic engineering and rapid reroute and all that other stuff, because I was designing clouds. Now, the rest of my team here, most of these guys have a lot of enterprise networking experience. And believe me, enterprise networks have a whole lot more stuff on it than the clouds. So they had to get geeky and all these other things, which I wouldn't use. Oh, hi, princess. You coming in to tell me that you want to go outside and chase lizards? My cat comes in. She's the cutest little thing you've ever seen. I bought her for my wife and then found out that I love cats. But that's neither here nor there. But my cat may be a believer. But the point is all of us in networking all works on different things, which is why I want to bring in a great team for you. Because my background's different than Mark's, which is different than Benedict, which is different than those. And they're all great. And every one of us has their own knowledge. You want to say hello to people and show everybody how beautiful you are? This is my cat, Cindy. She doesn't love to be picked up, but she is very special. Yes, I will put you down. Okay, I'm sorry.
She had her 5 seconds of fame.
She had her 5 seconds of fame over there.
And
Mark, you guys take the next question for me?
Yeah.
And I'm going to go take her outside because she wants to go out. I'll be right back.
Okay.
Before we take the next question, I do want to get Mo's opinion on this in a second too, the virtualization, because Mo has a bit different experience than both Benedict and myself. But I'm going to put it this way to everybody. Depending on the environment that you work in, you'll come across the requirement or the need for different technologies. And that's also going to dictate very much on what are you going to dive more deeper into it, right? So for example, if you work for a company that is predominantly related to cloud, well, let's be honest. How much local area networking switching are you really going to be doing on a day-to-day basis? You might remember the basics, right? Different spanning tree versions, if it's going to be rapid per VLAN, if it's going to be multiple spanning tree. You'll of course remember the fundamentals, such as what is a VLAN, what is a VLAN used for. But what if you don't work on these technologies every day, and all of a sudden you get a problem, and you got to start messing with port identifiers, port priorities, and spanning tree? You may not necessarily remember all these things. Now, that doesn't make you a bad architect or engineer in that case, but the reality is you just don't deal with it a lot. So if you're in an environment that has a lot of virtualization, in this case, the cloud environment does, pretty much everything is virtualized and then presented to you in a form like Mo mentioned in a dashboard, where all the complexity, all the details of it is actually hidden from you. Well, guess what? You'll have to learn a little bit more about this kind of virtualization technology. What is it? How does it work, right? What makes it tick? And what are some of the use cases? But in your day-to-day job, Mo, what have you seen virtualization-wise, especially on the networking side and the cloud?
Yeah, to Angel's question or Angel's point, I agree. I think knowing what virtualization is at a fundamental level is very important to dealing and working with cloud systems or any sort of virtualization, right? But both of you mentioned very good points on different examples of virtualization, right? But it all falls, just like you said, VLANs, right? That's a virtualization, right? When we're doing trunking over between switches instead of traffic, right? We're creating a virtualization by distinguishing different networks, right, by a specific tag. We call it a VLAN. VPNs, right, virtual private networks. Those tunnels that we create, this is some sort of a virtualization, right? You're virtualizing your environment by creating tunnels or VLAN tags or whatever, right? But what's what's the purpose of having the virtualization here is that what you're trying to do is you're trying to at the end of the day, you're trying to simplify a connection from point A, at least from the network's perspective, right? From your point A to point B, you're sending your traffic, you're tunneling that traffic, but from the user side, they don't need to know that information, right? They don't need to know how one person in China can talk to another person in New York over a direct tunnel, or at least from their perspective, it's a direct tunnel, right? They don't need to know that low-level details of how we create and establish that tunnel that facilitates that communication. So I think it all comes down to virtualization is how to simplify from a network perspective, right? How to simplify the network so that, without how to facilitate that connection over a complex, could be thousands of hops along the way without the end user having to deal with that complexity, right? And that's what the cloud does too. Right.
And here we go again at the abstraction discussion, right? Something that gets hidden from us, and at the same time, even though the complexity is hidden, it does always rear its ugly head eventually, because if something breaks, somebody's going to have to fix it. Yes. And if it's designed improperly, guess what? Eventually it's going to break because some things weren't actually considered in that sense. So I agree with you. So from Jason Texera, he says, I'm gathering that the pursuing cloud certifications are really vendor serving. It would seem that pursuing the CCNA, CCNP would prepare us better in a broader context than just an AWS certification.
Okay, Jason, I'm going to actually answer this question and we'll get the rest of the team. So there are some certifications which I find incredibly valuable. The Cisco Certified Internet Expert, because there's no way you're going to pass that exam and not know networking, at least in 95% of the cases. The CISSP, fantastic cybersecurity certification. And what's different about these two? Well, to pass the CCIE, you need to know something. When everybody else is stacking up 40 and 50 junior level certifications, you're developing some expertise, which employers really need that expertise. They don't need somebody that knows a little about how to do 20 people's jobs. They need someone really great at their job. So there's that. You know why I love the CISSP? Because it doesn't have any vendor's information in it whatsoever. It talks about designing security concepts, and it's teaching you how to be good at your job. It's a certification, and all certifications are always going to be intro level, because intro level is more about doing, and the more strategic levels are more about planning. The CISSP is more about planning, but they don't get very deep on anything. But again, I like it. Now, the CCNP, that Cisco Certified Network Professional, that could go either way. How many exams were there when you took it, Benedict? 3 or 4?
There were 4.
Okay. When Benedict and me and Mark and probably Mo did our CCNPs, there were 4 exams. So it was about 10,000 plus pages of reading to pass this. The CCNA is 2,000 pages compared to, say, an AWS Solutions Architect Professional, which is about 500. So even the CCNA had about 4 times the AWS Solutions Architect Professional content. And the CCNP was at another 5,000 to 8,000 pages, and it was big. What do you think Cisco did recently, Jason? They cut the 4 exams down to 2. And by doing it, they reduced what you needed to learn for the CCNP. So why would a vendor do that? They want you to stack up in certifications because it's going to make you excited about their stuff. That certification then becomes more of a marketing thing. Let me bias you towards these things. You're going to be more likely to like them. And that's why I love the CISSP. Truthfully, Jason, and I never recommend them, and I'll tell you why I never recommend them. The CompTIA certifications are actually really good. They typically have a very good framework, which is not related to the vendor. Why do I not typically like them? Because they don't have a good brand. And people typically think of a CompTIA, A+, Net+, working at the Best Buy Geek Spot, or working on help desk other than being an architect. It's not that the certifications aren't good. They're very good certifications. But they don't have the brand, and certifications are to get you an interview. So we want to get the best bait we have when we take our certifications to get the best interview. And then it's what you do after. I like to say that the CCIE was my intro to networking. And actually, I've got 3 CCIEs on this call, so I'll ask them that same perception. I can tell you that, Mark, what it cost you in terms of time and money to do your CCIE, pass it, all the training that was needed.
The CCIE, I got away a lot cheaper than most people since I virtualized a lot and had different subscriptions. I would probably say I spent less than actually probably $10,000 roughly.
Okay.
I'm guessing there because I didn't keep track of it because guess what? I had to pay for it. I didn't get reimbursed for it. So that was the case. Time-wise, so it depends. I don't know the total time, but it definitely took me over a year with a full-time job to do it. But in a week's time, roughly what my schedule looked like is at least an hour to 2 either before work, or I would break it up. So I would do an hour before work, generally speaking, especially at the CCIE level. That would be more my reading, theory type of work. And then another probably about an hour after work, if I could do it. And then, of course, again, the CCIE was a very hands-on type of exam. You had to, one of the skills you had to have on the CCIE is you had to be quick, right? So otherwise, if somebody gave you a week, you can probably get it done. But the point is they gave you such a short amount of time to get something done that would normally take you a week that you had to practice on speed. So generally speaking, at least maybe 8-9 hours on the weekend, just spent labbing the whole time. So what is that? That's about, let's say, 16 hours plus the other 5, that's 10. So let's be nice, anywhere from 20 to 30 additional hours that I spent in a week just working on the CCIE. That was
I'll tell you guys, and that's a lot. And you got off cheap at $10,000. I don't know anybody that paid that little. And you got off. And then I'll ask Mo, and then I'll tell you what I actually did. Now, what did your CCIE cost you for all the training necessary to get it done, all the books you did, all the labs you had to do?
Yeah, I actually kept track of everything I spent, and between the physical lab I had at a time, and then the actual servers I bought, the rack rentals, what we call rack rentals, which is basically using somebody else's racks or servers and actual network equipment. And then you have all the books, the subscription to different websites, like at the time Safari Books Online and so on and so forth, which is now O'Reilly. I would say about, and I forgot the exact number, but it's in the 20,000 something, about 24 to 27.
That sounds more normal.
Yeah.
And how long?
It took me about 4 years and a half. I still remember it because the way I studied, actually, I got a very good. At the time, I was still in North Africa, and I wanted to get the opinion of the experts. So I looked online. At the time, it was on one of Cisco's communities when they were very active at a time, and it was one architect who suggested that if you want to pass the CCNA, read at a level of a CCNB. And if you wanted to pass the CCNB, read beyond the CCNB. So try to go for CCIE books. And that's what I've done. I actually finished the CCNB training before I even did my CCNA. And by the time I did my CCNBs, I've already finished 2 CCIE level books. And so I passed this. I passed my CCNB early 2015, I believe January, and that's when I decided, it made sense for me to start my CCIE journey. And I think we can all agree that when you start your CCIE, it always starts. You start with an unrealistic goal and say, you know what, I'll do it. In 6 months. If the CCNB took me this much, the CCIE probably gonna take. And then you realize that how much goes into it, and one book turns into 20 books, and one boot camp turns into 4 boot camps. So it's really, I'll definitely, if I knew, to be quite honest, if I knew that will take me 4 years and a half, I would have probably delayed it and went for something else. But because I've already started, and 8 months in, it was already too late for me to change.
You're not a quitter.
Yeah, exactly. Yeah. I'm not a quitter. So, it's really, it's a long investment, right? And that's the thing for the CCNA and CCNP. I would say they're also, they're big investments, but to go back to your question, Jason, is would you go for a cloud or a cloud-specific certificate, or would you start with the CCNA and the CCNP? I would say yes to both. I would think you need to do both at the same time, right? And it seems to me that your goal is to become a cloud architect or engineer. And if that's the case, you do need the AWS knowledge in order to work AWS, but you're not going to go far without the networking foundation, right? And the CCNA and the CCNP, I believe, to this day, they're still one of the best foundational certificates if you want to understand networking and how networking works.
Yeah. And I'll
Now,
tell you,
I have a question, Mike, if you don't mind, because I want to see if this is the big reason between Mo and myself. You said boot camps. Did I hear you right?
Yes.
How many did you take?
Without naming actual.
Yeah,
vendor,
don't name
right?
the person. Just
yes. I've taken 3 boot camps.
okay.
One boot camp I've done 3 times. I didn't pay for it 3 times. Actually, it was because I was going through things at the time, and the vendor, they were really nice, and they actually let me take it multiple times because I was taking care of somebody and I was at the hospital most of the time. So really, in reality, I've taken 3 different boot camps. And so,
Okay.
and that's not including all the different workbooks from different vendors, all the different actual, the advanced technology class, what we like to call, from different vendors.
And that brought up your pricing, right? The boot camps.
Yeah, definitely. The boot camps are the most expensive part, I would say.
Okay.
Yeah.
All right. Benedict, if you want to answer Justin's question, and then I'll give my take on it.
I would say having both certifications are good. The only difference is that the CCNA, CCNP gives you broader knowledge than what the AWS certification would give you. But if you're working in an organization that has their resources in the AWS cloud, then it pays to have the AWS certification as well, so that you can, grow in that organization. So it helps to have both certifications if you can. It's just that the CCNA, CCNP gives you broader knowledge.
yes. And then Jason, because you want to be an architect, don't put the CCNA and CCNP on your resume. Just put the CCNP, the professional one, because we don't want to have as architects too many certifications. We want to have good, focused, strong certifications. But there's that. But I echo everything that Benedict said there. Let's say I have a security architect. The CISSP is going to be the certification that matters. But let's say they've done an Azure Solutions Architect Expert. Boy, that's interesting, AI. Or the AWS Solutions Architect Professional, either or. That looks good, right? Now they get a CISSP, which shows strength and security. And now let's say they're on AWS. They do the AWS Security Specialty. That hits 3 professional level certifications, which is about as much as we don't anymore. We got a big one that gives you your knowledge. You got the AWS one that shows strong familiarity with AWS. You marry them 2 together, and then you get your training to learn your security architecture, which is the kind of training we provide. And now you've got a good portfolio. Those certifications will get you that interview. You get the CISSP, and that might even give you 20% of the knowledge you actually need on security. You combine these things together, and you've got magic. So, I hope that answered your question, Jason.
Yeah, and Jason, if you consider what we spoke about earlier and the questions that I asked both Benedict and Mo in regards to what type of foundational knowledge of networking is actually present that would be taught in the AWS Advanced Networking exam, you should have noticed there that it says pretty much none. It was non-existent. And what happens to a lot of these vendor certifications, and just so you understand, all of them are self-serving to the vendors in one way or another. Either if it's going to be to some proprietary solution that they give you, or in other cases, the more certified people in a particular solution, that is also advertisement. Because those people, what you know well, you're going to go market, right? So if you're good at, let's say, at something Cisco related, you want to talk about it. You're going to promote it. Same with AWS. If you have over 1 million people that are certified As solution architects, guess what? That's 1 million people that are going to promote your product. So from those perspective, every certification, regardless of vendor, is going to serve them. But when you look at the certifications themselves, like in this case, when we have the workshop, they infer a level of understanding. So in that case, if they're not teaching you the fundamentals so that you can understand what they're trying to get you to in that particular exam, like this one, then other certification, let's say like the CCNA, like the CCNP, might help you bridge that gap so that you can understand something else. But for example, when we look at this exam, and Mo and Benedict are probably going to cover it as well, is if you look at a technology like VPLS, guess what? You will not see that on what we consider your traditional kind of CCNA and CCNP certifications in the enterprise. To be able to see something like that, you now have to switch towards the service provider domain because it's part of a transport circuit delivery, right? So, and then you would also have to understand, as Mo brought out earlier, some type of virtualization, because that's what VPL is too, right? So it really is going to depend on what your end goal is, where you're trying to go to. When it comes to a job, certifications are great. That might give you an interview. In the exam though preparation, that's really going to prepare on what your foundation is and what your end goal is.
Yeah.
Question from Shihab. What is the difference between a DevOps engineer and a cloud engineer?
Well, the line gets a little bit blurry, Chaudhry, but let's talk about the difference. So a DevOps engineer, if they're doing true DevOps, is about setting up new releases and ways to automate the release of software. It's the merging of software development and software engineer. So a really good DevOps engineer should be a software developer who's then learning the operations and they're learning the DevOps tools. Now, because of the automation component of DevOps, because of all these CI/CD type pipelines, it tends to fit very nicely into cloud computing, where you can write a script like an infrastructure as code script, like a Terraform script, to deploy things. So because of that, you see a lot of DevOps engineers almost doing super cloud engineer jobs, because they're doing a lot of the cloud engineering work, which is building. Architects design, engineers build. So they're building it, but they might also be related to software release cycles, planning new software, automation, setting up, containerized environments like Kubernetes clusters and things like that. But there's a big development component in the DevOps engineer. The cloud engineer, by comparison, is building the systems designed by the cloud architect. So while cloud architects don't code, cloud engineers will code. While cloud architects don't use Linux, cloud engineers will need to know Linux. So the cloud engineer is going to be the builder of the cloud. They're going to be hands-on with servers. They're going to be hands-on with administering servers. They're going to be hands-on writing an automation script in Python or Linux Bash or Windows PowerShell. They're going to be creating infrastructure as code now, just like a DevOps engineer. And some cloud engineers may even get involved in some DevOps pipelines as well. So the lines between those two are blurring. Now, the architect is an executive. There's no blur between the architect and the engineers, but in the DevOps engineering and cloud engineering space. But there's also DevOps engineers that don't work with cloud computing at all. They work in the data center and they work on automation of software release cycles. And there's DevOps architects that don't really, that are architecting DevOps pipelines and things. So DevOps is its own career, but like any of these careers, sometimes the lines get a little blurry with them. But I hope that answered your question.
Don't be shy, everybody. If you have any questions for the upcoming workshop, be sure to ask them.
And in the meantime, I'll get to remind everybody that we've got a free AWS Advanced Networking Bootcamp coming on Friday, Saturday, and Sunday. Sign up. The link's in the chat box in the description.
So we have a question from Mohammed. He's wondering if there's going to be IPv6-based labs on the upcoming AWS Advanced Bootcamp. Looks like to reduce the usage of public IP addresses. I'm assuming IPv4.
So for us, I like to, I studied Taekwondo and Shotokan karate, okay? And then I went and sparred with a martial artist from the military. And I learned very, very quickly that karate did not work in the environment that I needed it to. So there's an expression among those that are combat trained that says, train the way you fight. So, I'll let Mo talk a little bit more about this, and then I'll tell you my perspective of IPv4 versus IPv6 in the modern world, given that 99% of everything is IPv4, except for cell phones, which are IPv6. But Mo, you put together some labs.
Yeah, absolutely. To answer your question simply, I would say yes, we do have IPv6 on the labs. I would say two of the labs actually provide a basic IPv6 demonstration. Also, we do go over IPv6 on the bootcamp, so you'll have more understanding of IP6, IP version 6 there. I'm not sure if that answers your question, but Mike, if you want me to dig more into.
I think he was asking, would a lab to deploy IPv6 reduce the number of public IPv4s used? And the answer is yes, but we have to consider about how many. I mean, a lab using 1 or 2 IPv4 addresses is no big deal. In an enterprise environment, most customers don't use that many IP addresses either, because most of it's private addresses. Long term in the future, if we've got to put IP addresses on cell phones, that's going to be IPv6 because there's just too many mobile devices. Internet of Things devices, where we're going to have sensors everywhere, that feels very like IPv6 oriented, where you're going to want to use it. And at some point, we'll actually have more IPv6 things. But the IPv6 thing is kind of funny, because when I started networking, we were going to be using IPv6. No, because we ran out of addresses. Now, then there was actually an argument in the network architecture space. Should we use CLNS addressing or should we use IPv6 addressing? It turned out we built half of our internet service provider networks using CLNS routing protocol called intermediate systems to intermediate systems. Not an IP-based routing protocol to route IP. But for the most part, it's still IPv4. And who knows when IPv6 will actually become mainstream.
Yeah, there's a lot of debate on that, whether IPv4 is still a necessity at this point.
Yeah.
Is it more of a sunk cost, the reason, or is it just companies that have, they have, I guess, motives or financial benefits by sticking to IPv4 versus moving to IPv6? But I think we can all agree that eventually we will be moving to a fully IPv6, whether that's 30 or 50 years. I can't tell you that, right? But there's definitely a huge benefit of moving to an IP version 6 infrastructure if you can do it, right? Yeah. If it actually can be done, right? Because some infrastructures, some applications or infrastructures, you just can't go to a complete IP version 6 infrastructure. So what you end up finding is that actually introducing IP version 6 to your infrastructure might actually complicate your network instead of simplifying it, because you still have to support the existing IP version 4 infrastructure, and then you have to deal with things like NAT64 and DNS64 and finding a way for your IP version 4 applications to interact with your IPv6 applications, and doing something like dual stacking where you use them both. And that's, I think, one of the big reasons where companies shy away from using IPv6. I don't think it's just not understanding IPv6, but more of the cost of actually having to support both, because it's really difficult to just get rid of IPv4 and support IPv6. But obviously, the benefit of the number of IP version 6 is almost virtually impossible to run out of IP version 6 IPs, and that's the huge benefit that you get there, obviously. And there are some security benefits as well.
Yeah, well, if you ask me, I don't think we are going to be seeing the end of IP version 4 in this lifetime, because it's just so easy to use it, And then we have network address translation as well, which helps in, imagine reducing the number of IP version 4 addresses. I've worked in 2 organizations now that have undergone mergers and have become bigger in space, and IP version 6 was the last thing on our mind. Instead, we just increased the private subnet range and worked with our subnetting and supernetting just to keep the addressing. So I think we're still going to be seeing lots of IP version 4 in use for a long time. Mobile phones, Internet of Things devices, which do not really matter, can do with IP version 6. There's no problem there. That's what I think.
Yeah.
Well, based on history and how many people have tried to foretell the future when we'll live in an IPv6 based world, I can tell you from experience, it's a futile endeavor to try to speculate when IPv6 will become mainstream. But I would definitely say that one question you would have to ask yourself, and Mo kind of alluded to it, there is a cost aspect of trying to transition from one technology to the other. So as a business is always going to take cost into account. Then the other one is it really necessary? What is it that a particular business is lacking by using IPv4 compared to IPv6? That's also something you have to consider. If there's no aspects that you're missing from that perspective, then what is the benefit of going to IPv6? Besides the obvious, some might tell you have a larger address space, you have inherent security because IPsec is a requirement, unlike an IPv4 where it's not. So, but besides that, what would be your selling point on it? The networking nerd would tell you, well, it's been around since, like 20 years now or something like that. We should finally move to it. I've studied for it. I invested time learning it. But aside from that, what is the actual benefit from a business to using it? I'll leave you with that question. So question from Mohammed, is there any differences between a network engineer and a cloud engineer?
Well, in reality, for real companies, no. If a company was 100% cloud-based, the answer would be yes. So here's the reality, Mohammed. 98% of organizations use more than one cloud. And there's a huge trend towards private clouds and hybrid multi-clouds. So what does that mean? It means we need to build a data center. We need to have our interior gateway protocols. We're going to need to connect to external entity and exterior gateway protocols. On the high performance stuff, we're going to need to put in our LAN with our QoS. We're going to need to optimize our wired network, which is all pure network engineer stuff. And then we're going to have the stuff in the cloud, which is basically going to be, for example, our transit gateway, which is basically a router with less functionality. It's going to be our VPCs, which, have reduced networking capabilities than we do in our data center, but they still have some. It's going to be getting involved in working around all the weaknesses inside of the cloud, because cloud networking is honestly about 20 years behind. So compared to what we've actually done in the data center. So we're just about catching up to, say, 1999 to the Area 2000 on the cloud. So for the most part, they're the same. Now, where might they be different? Because there's less to do on the cloud. A cloud network engineer might need to code in their job. Whereas, Benedict, you code in your job in networking when you were a network engineer?
Nope.
Mark, did you code in your job as a network engineer?
I told them no when they asked me.
Mo, did you code in your job as a network engineer?
I have not, no.
And I've been a network engineer for so long that before I was a network architect, we didn't code. So there's that. So more complexity in the data center. So in the traditional network engineer, there's more you need to know here about how to tune the things, what we like to call nerd knobs, how to set it up. In the cloud, it's going to work, and it's going to work easier, and there's less to know. So if there's less to know, one of two things are going to happen. Product one is you're going to get paid less because it's simpler, or the option is they give you more stuff to do. So that cloud network engineer may actually get involved in load balancers, which are not typically networking. They may get involved in DNS, which is not typically network engineer work to do. So they're the same, but because the cloud is a little more simple and elegant, the cloud network engineer won't get as deep in networking, and they're going to get deeper in a whole bunch of other stuff that network engineers don't do. But all in all, the rest is the same. I know we're short on time, and we've got some questions, so let's go to the next one.
From Gwet, do I need to have a CCNA or CCNP level to move to the AWS Advanced Networking?
So no, I mean, the AWS Advanced Networking, you could just do it. I will tell you the AWS Advanced Networking is going to be a lot easier than, say, a CCNP. So big difference, maybe the equivalent of 300 to 500 pages of reading versus, 5 to 8,000. So no, you can definitely do this. I like to use the AWS Advanced Networking as an intro to networking for people. I think it's a great introduction to cloud networking. And no, you can do that as your first thing, Jules.
Yeah, so having the CCNA or CCNP is not a requirement for the AWS Advanced Networking. It helps to have the basic networking knowledge to go for the AWS Advanced Networking and pass the exam, but it's not a requirement.
Yeah, absolutely. I would have to agree with both Mike and Benedict here. It does give you an advantage if you know that level of you have that level of understanding of networking, but it really is not necessary, right? I would say networking on the cloud is simpler, right? A lot of the components that we use on premise, you don't use on the cloud, but having that knowledge can give you the advantage of being able to say, oh, a transit gateway, what's a transit gateway? It's just a router, right? So it gives you that contrast of something similar on premise or, on traditional networking that you can help you understand those cloud components really, but it's not a necessity. I'd say if you're starting off, you don't have that knowledge, that's fine. Just learn as you go. What I would say, learn what you find is necessary as you move forward.
Question from Cantor. Hello, Fantastic Four. Love that name. When I add a redundant connection from the data center to the public cloud using a different provider, I can't use link aggregation. Does BGP allow to use both connections and leverage something similar to load share in them?
So good news for you, Cantor Grant. The answer is yes, we can load share with BGP. In fact, there's a free book in the description of this video, and if it's not, my team can pop it in the chat box on how to do it. And Mark and I last week did a 7-hour BGP workshop where we showed you how to load share across 2 different connections using BGP. We talked about route leaking. We showed you how to do it by manipulating the weight. We showed you how to do it by manipulating the local preference. We showed you how to do it by manipulating the AS path. We showed you how to do it by manipulating the origin code. So yes, the answer is something you can do. It's not going to be on a packet by packet networking like you would get with, say, a link aggregation group, but it's going to be based on routing policy that you can definitely traffic engineer. And Cantor, when an enterprise connects to multiple internet service providers, they use BGP to do the same thing to load share across them. Very similar architecture. And yes, so please watch that 7.5-hour video. We describe it. We go over deeply the protocol. We show you how to do it, and then Mark even demos it. And I think you'll like it. And please, while you're at it, get the free BGP guide. And actually, for all of you that are here, get the free BGP guide. Get as many of these free things as you can. They're in the description of this video. So there's that. So I think we hit our 8 o'clock at night. So I can't keep all these people this late. They've got wives and family members and cats and other friends and things that they have to take care of. So please join us on Friday for the AWS Networking Bootcamp. It's going to be fun. You can see the team of people here. They've got 60 plus years of experience in networking. They're going to make it great. When I hear Benedict speak, I always get excited. And truthfully told, I've learned something, even though I've been networking for 30 years. When I hear Mo speak, sometimes it terrifies me because he's so smart, but I always learn something from him. And he talked to me about an east-west traffic inspection thing one time at an offsite, and I was blown away. And Mark, Mark, he's with me a lot of the time. There's a reason it took me a year to bring him on. I couldn't wait to get him on. And as soon as I could steal him from another company, he joined us. So come to this free webinar. And take care, everyone. So thanks so much. See you Friday. Give the video a like. If you have, share this video with somebody else to invite them to the free training. We'll see you there. Have a great night, everyone.
Thank you, everybody. See you this weekend.